Welcome back to the deep dive. This is where we take all those sources you send us, the articles, the research papers, the notes, and really try to piece together a clear picture.
That's right.
And today, we're tackling a big one, Qwen3 VL. It's the new multimodal AI that Alibaba dropped on, what was it, September 23rd, 2025?
Yep, that's one. And based on the materials you forwarded, it's definitely being talked about as more than just, another incremental step.
Exactly. Feels like they're positioning it as maybe a quantum leap. Our goal here is to really unpack Qwen3 VL, figure out how it's pushing the boundaries of these vision language models or VLMs, and understand why it's such a potential game changer right now in late 2025.
Absolutely. And just to set the stage, when we talk multimodal AI, we're talking about systems where language and vision aren't just separate inputs, they're truly integrated. They work together.
Right, language kind of marries vision.
Precisely. And Qwen3 VL seems to be the latest, maybe even the most powerful example of this. It's not just about identifying objects in a picture anymore. It's about understanding, like, the visual chaos. Your source is mentioned, complex diagrams, long videos, messy real-world scenes.
And there's a crucial detail right out of the gate that we have to mention, something that changes the whole dynamic.
The open source license?
Yeah, exactly. It's under Apache 2.0. This level of AI power just out there for potentially anyone to use and build on.
That's a massive deal.
Yeah.
It really democratizes things. Instead of being locked behind a proprietary API, researchers, startups, everyone gets access. It could really accelerate the whole field.
Okay, so let's dig into the engine room a bit. A vision language model, a VLM. Can you give us a quick refresher? It's not just sticking an image model next to a language model, is it?
No, not really. Not for these advanced ones. It's about fusing the text processing strengths of a large language model, an LLM, with, really sophisticated computer vision capabilities, often using something like a vision transformer or VIT.
So they talk to each other deeply within the architecture.
Right. The goal is true synthesis, processing both types of information simultaneously. That's how you get that deeper cross-modal reasoning needed for complex tasks. It sees the image and reads the text together.
Got it. Now, the flagship model they announced, Qwen3 VL235B A22B, that first number, 235 billion parameters. That sounds computationally terrifying.
It does. It's a huge number. But the key, and your sources rightly highlight this, is the second part, A22BB. That points to the architecture.
The MOE, mixture of experts.
Exactly. It has 235 billion total parameters. But thanks to this MOE structure, only about 22 billion are actually active for any given token it processes during inference.
Okay, wait, so how does that work? What is a mixture of experts doing here? Is it like
Should-
different parts of the brain specialize?
That's a great analogy. Think of the 235 billion parameters as a huge team of super specialists. When a task comes in, maybe analyzing a medical image or translating some text, a router mechanism instantly figures out which small group of experts, adding up to 22 billion parameters, is best suited for that specific job.
Ah, okay, so it only calls up the necessary specialists instead of activating the entire massive model every single time.
Precisely. It's like having access to the whole library of expertise, but only paying the computational cost for the specific experts you need at that moment. It dramatically saves energy, GPU power, you name it.
That makes that huge parameter count seem much more manageable, at least computationally, for actual deployment.
It does, and they've also got different flavors, right? There's an instruct variant for quicker, more direct tasks, and then a thinking variant that's designed for more complex multi-step reasoning.
And there was something about hardware efficiency, too. FT8.
Yes, FP8 support. That's floating point 8. It means the model uses numbers with slightly less precision for its calculations. You sacrifice a tiny bit of accuracy, often negligible in practice, for significant speedups and lower memory use, especially on modern hardware like NVIDIA's H100 GPUs. Makes inference much faster and cheaper.
Okay, so the architecture is clever. Let's shift to what it can actually do. This is where it gets really interesting, right? The capabilities. First up, context mastery. The numbers here seem wild.
They are pretty staggering. Native support for 256,000 tokens. And apparently, the architecture is designed to potentially scale up to 1 million tokens.
1 million tokens in a multimodal model. What does that actually let you do? Like read a whole book with pictures?
Pretty much, yeah. Think about
Yeah.
processing, say, a 500-page PDF report filled with text, charts, and images. This model could potentially ingest the whole thing, understand the text and the visuals, extract key data, maybe even write an executive summary, all without losing track of what was said on page 10 versus page 450.
Okay, that's not just reading. That's deep comprehension across massive amounts of mixed data. That could totally change workflows in fields like law or finance.
Absolutely. It moves beyond just summarizing text to synthesizing information from complex, visually rich documents end to end. That's a big step.
And the vision side isn't just about recognizing things, right? You mentioned spatial reasoning. It goes beyond just saying, there's a cup.
Right. It's about understanding where things are in relation to each other.
Yeah.
It does 2D and 3D grounding. It understands occlusion, like if one object is blocking the view of another. The claim is state-of-the-art performance on benchmarks testing this.
So if we use that classic messy kitchen example,
Yeah.
what does Qwen3 VL tell us that others might not?
Instead of just listing sink, plate, knife, it could potentially say the knife is partially hidden behind the blue plate, roughly 30 centimeters to the right of the tap, oriented at a 45-degree angle. That level of detail is crucial for things like robotics or augmented reality, where precise spatial understanding matters.
Okay, that's impressive. What about video? That's usually a tough nut to crack for AI, especially long videos.
Yeah, models often lose track after a few minutes,
Yep.
but Qwen3 VLVL claims to handle videos hours long, keeping track of everything and indexing it down to the second.
How? Is there a specific trick?
They mention using text timestamp alignment. It sounds like a technique to very precisely link what's happening or being said in the video to the exact timestamp.
So you could ask what happened around the 2-hour, 15-minute, 30-second mark, and it could tell you accurately.
That seems to be the idea. The sources say performs competitively on video question-answering tasks where others struggle with long sequences. Think about analyzing hours of security footage or reviewing complex procedures. That temporal recall is key.
Okay, context, space, time. Now, the really disruptive part, agentic capabilities and OCR. Let's start with OCR.
Right. Optical character recognition. It supposedly supports 32 languages and handles tough conditions, blurry text, weird angles, low light. They're reporting big gains on benchmarks like DocVQA, which involves understanding text within complex documents.
32 languages is quite broad, but the agentic part, that sounds like it moves beyond just understanding to actually doing things.
Exactly. This is the wow factor. Right. It's not just seeing a button on a screen, it's understanding the goal and figuring out the steps to take. It can apparently recognize GUI elements, buttons, menus, text fields on computer screens or mobile apps.
So you could tell it, book me the cheapest flight to London next Tuesday, maybe show it a screenshot of the airline website, and it could navigate the site and do it.
Potentially, yes. Or find this specific product on this e-commerce page and add it to my cart. It acts like an autonomous agent within that digital environment. That has huge implications for automation.
And it even generates code.
Yeah, apparently it can generate diagrams for tools like draw.io or even functional HTML, CSS, and JavaScript code directly from an image, like a hand-drawn wireframe or a mockup.
Wow, okay. And how does it fare on really tough academic tests like those complex reasoning benchmarks?
It seems to hold its own. Your notes mentioned it matching or even surpassing models like Google's Gemini 2.5 Pro on perception-heavy benchmarks like Math Vision and MMMU Pro.
MMMU Pro, that tests really complex multimodal reasoning, right?
Exactly. Doing well there suggests the underlying architecture, the fusion of the vision model, and the mixture of experts LLM, which they call deep stack, is delivering genuine high-level reasoning, not just pattern matching.
That's a powerful suite of capabilities. All right, let's pivot slightly. We need to look at the evidence. How does Qwen3 VL actually stack up against the competition according to the benchmarks?
Okay, so based on the initial, and we should stress self-reported, benchmarks.
Right, always got to take those with a grain of salt initially.
Definitely. But according to those, the thinking variant is hitting state-of-the-art, or SOTA, on several multimodal reasoning benchmarks. Things like Hallusion Bench, which tests if the model hallucinates or makes basic visual errors, and Math Vision, which involves mathematical reasoning based on visual input.
So assuming those results hold up under wider scrutiny, where does it really shine compared to, say, GPT-4o or the latest Llama?
It seems to carve out its own strengths. GPT-4o is often cited as being fantastic with fine-grained detail in images, but maybe less strong on very long video or text contexts where Qwen3 VL claims an edge.
And Llama?
Llama 3.2, especially the smaller versions, is pushing hard on efficiency for edge devices. But based on current info, it seems to lag behind Qwen3 VL in areas like complex video understanding or those advanced agentic capabilities.
So Qwen3 VL's niche seems to be that combination of massive context, deep video analysis, multilingual OCR, and the ability to act as an agent.
That looks like the key differentiator package, yeah. The agentic skills and the long context mastery seem particularly strong points in their claims. And the academic papers they reference, like those potentially heading to NeuraPS 2024, seem to back the architectural choices like MoE and the V/T fusion.
Okay, but it can't all be smooth sailing. Every major AI launch has its caveats, its asterisks. Let's unpack the challenges here. What are the potential shadows?
Well, the first and most obvious one, despite the clever architecture, is still the hardware.
Even with MoE and FT8.
Even with those optimizations, running a 235 billion parameter model effectively still requires serious GPU power. We're talking clusters, not just a single high-end card for many serious applications.
So it's open source, technically free to download, but the cost of entry is still the hardware needed to actually run it well. Kind of ironic, isn't it?
It is. It's the big bottleneck in truly democratizing this level of AI. Access to the model is one thing, access to the necessary compute is another, especially for researchers or developers outside big tech or well-funded institutions.
Right. What else? The performance claims themselves.
Yeah, the need for independent verification. As we said, the initial benchmarks are promising but self-reported. The community needs time to rigorously test these claims against rivals like GPT-4o, Gemini 2.5 Pro, Llama 3.2, especially as those models are also evolving rapidly.
And part of that testing involves checking for biases, right? Like how well it understands things outside a Western context.
Exactly. How does it handle cultural nuances, different visual languages, memes from various regions? That kind of testing is crucial for a model aiming for global relevance.
And then there are the ethical dimensions, particularly with that powerful video analysis.
For sure. The ability to analyze hours of video footage with high precision immediately brings up concerns about surveillance, potential misuse. Alibaba will need to be transparent about guidelines and safeguards.
But they won. And one last practical hurdle, especially for global teams.
Often, it's the documentation and community support. Even with 32-language OCR, if the core documentation, the tutorials, the main developer forums are primarily in Chinese, it can slow down adoption for teams elsewhere, like in Europe or the Americas, including the large Spanish-speaking developer community. It adds friction, even with an open license.
So these aren't necessarily fatal flaws, but they're real-world hurdles to overcome in a very competitive space.
Exactly. Hurdles you'd expect when pushing the boundaries this hard.
So wrapping this up, the big picture takeaway seems clear. Qwen3 VL really underscores that Chinese AI innovation isn't just catching up, it's actively setting new benchmarks, particularly in making powerful multimodal tools open and accessible.
It puts serious capabilities, advanced vision, long context, agentic functions potentially into the hands of many more developers globally.
And if you, the listener, want to get a feel for it, the sources mentioned a demo on Hugging Face that's apparently quite compelling, especially the visual agent stuff.
Yeah, definitely worth checking out if you want a taste of what it can do.
Which brings us to our final thought, something for you to chew on. We've just discussed an AI that can potentially digest a massive, complex report with visuals, understand hours of video precisely, and even execute tasks based on a simple sketch.
It sees, understands context, and acts.
Right. So the question is, what does this new level of agentic visual intelligence really mean for the future of work, for professional automation, for how we collaborate with machines over, say, the next 2 years, when the machine might genuinely see and remember context better than we do in certain tasks? Are we ready to delegate truly complex, context-heavy work?
It definitely pushes us to think about what tasks remain uniquely human and how quickly that might change.
Food for thought. Thanks for tuning into this deep dive. We'll see you next time.